Alright, so we went over what percent composition by mass is. Now we're going to use percent composition by mass, and we're actually going to work backwards. So the question is, we have vitamin C, and the question says, vitamin C has 40.92% by mass of carbon, 4.58% by mass of hydrogen, and 54.50% by mass of oxygen. So all these percentages are by mass. And it wants us to find the empirical formula. So how do we find the empirical formula? Okay, so before, when we were doing percent composition by mass, we were starting with the moles, or we're starting with the molecular formula, and we converted that, and molecular formula is a mole ratio, so we went from moles to percent by mass. But now we're going to go from percent by mass to moles. So when you get a question like this, the first thing you have to do is you're going to assume, let me write it right here. You're going to assume that you have, let me do a different color too, 100 grams of vitamin C. Alright? And it's going to make sense in about 2 seconds. The reason why we do 100 grams, assume 100 grams, is because if we assume we have 100 grams of vitamin C, then how many grams of carbon do we have? Well, if 40.92% is carbon, 40.92% of 100 grams is going to be 40.92 grams of carbon. Okay? Then, same thing with hydrogen. No math required. So, we could have said 101 grams or 103 grams, but then we would have had to do some math there. But here it's just simply making things easy. So we assume 100 grams. Now, why can we assume 100 grams? Well, remember that these percentages are like a ratio. It doesn't matter how much you have, the ratio will always be the same. So we could have picked any amount, any gram amount, and this we could still work the problem out. But we just pick 100 grams to make it easy. Okay, so we pick 100 grams. Now we have 40.92 grams of carbon, 4.58 grams of hydrogen, and 54.50 grams of oxygen. Now, what we have to do is we have to convert all these quantities into moles. Okay, I know that looks weird, but remember that's 54.50 grams of oxygen. That's a zero. That's an oxygen. Alright, so let's convert this one. 40.92, man, I'm bad at writing nines, grams. We're going to use some dimensional analysis. Go watch the video if you're having trouble with this. Grams on the bottom to cancel out, moles on the top, and 1 mole of carbon, there are 12.0, what was it, 01? Let me check. Yeah, 01. 01 grams. So, and this comes out to be 3.407 moles of carbon. So I'm going to write this up here. This equals 3.407 moles. Alright, now we got to do hydrogen. Okay, I just learned how to move the screen, so we're going to try it out. If there's any problems, let me know. Alright, that's pretty cool. It's working out. We'll go back up. I just needed more room. Alright, so we're doing, oh man, what was the quantities? Oh yeah, 4.58 grams of hydrogen. We got to convert that to moles. Same thing, dimensional analysis. In 1 mole of hydrogen, there are 1.008 grams, and that's going to be 4.54 moles of hydrogen. Alright, let's try that screen moving again so we can write it up there. Alright, change back to green. Oh, I forgot how many moles. No, I didn't. Alright, screen moving again, going back down. Alright, oxygen, it's red. So oxygen we had 54.50 grams of oxygen. Dimensional analysis, 1 mole of oxygen, there are 16.00 grams, and that equals 3.406 moles of oxygen. Alright, going back up. Change it back to green. Okay, that equals 3.406 moles. Alright, so the reason I had to write it back up here again is so you could see this process that we did. Now, remember, empirical formula is just like a molecular formula, just simplified. So, let me write up here. We know the molecular formula is going to look something like this. Alright, I know this is going to look messy, but I'm going to put it down here. The vitamin C consists of carbon, hydrogen, and oxygen. So we know the molecular formula or empirical formula is going to look something like this. We just don't know these quantities right here. I'll put X, Y, and Z. We figure out those quantities, we have the empirical formula. And these quantities, X, Y, and Z, remember, in a chemical formula, these are basically in moles. This is a mole ratio. And this right here, what we started off with, was a percent by mass. And percent by mass can be considered a ratio based on mass. So all we did, this is a percentage, we just assumed we had 100 grams so we could easily convert this percent by mass into a mass. And now we have actual grams of the quantities, just easy because 100 grams. Now if we have the grams and we know what we're talking about, we can easily use the atomic mass or molar mass and convert it to how many moles we have. So going straight across, all three of these are equal. All three of these are equal. All three of these are equal. We just change the units from percent by mass into the corresponding moles. So basically what I'm trying to say is, let me rewrite this stuff down here because we need some more room. Man, I never had to change slides. I could just do this. Alright, learning. Videos will get better. Alright, let me rewrite this. So, that was ugly. Alright, I'll start over. 3.407 moles of carbon, 4.54 moles of hydrogen, yep, 3.406 moles of oxygen. Okay, so that's how many moles we have found. You know, it's just back up there. If you don't understand, you can rewind, have fun. But I'm going to keep going now. So, and then remember, this is the empirical formula right here. I was about to put a Z. That's supposed to be an oxygen. There's the Z. Now that we just found the corresponding moles, this 3.407, 4.54, and 3.406, this is the mole ratio now. So basically, this number right here, that's X. This number right here, that's Y. This number right here, that's Z. So if we go and plug that in, carbon 3.407, hydrogen 4.54, then oxygen 3.406. Alright, we did it. But we're not done. That looks really ugly. You can't do that. That's not allowed. You can't have it in fractions or decimals. These have to be whole numbers. So basically, how do we get these into whole numbers? Alright, so what you're going to have to do is when you actually find this mole ratio in the fraction or decimal form, you're going to divide all three of these numbers by the smallest one. Okay, so what is the smallest one? We have 3.407, 4.54, and 3.406. So if you really look at it real hard, you can tell this is the smallest one. So all we got to do is divide all of them by that number. All of them by that number. Okay, so let's pick a new color. Yeah, I'm in the mood for red. So now we come to, I'm going to write it over here. So 3.407 divided by 3.406. I'm going to save you guys some trouble, and you're just going to assume that's 1, because that's basically 1. So I'm going to put a 1 there. You don't usually write the 1, but I'm going to do it for you guys for right now. And then hydrogen. The 4.54 divided by 3.406, that equals 1.33. Yeah, that's good. And then the 3.406 divided by 3.406, well, if you plug that in your calculator, that should come out as 1 again. Okay? Alright, so now we have two of them reduced to whole numbers, or in whole numbers, so those are good. But one of them is still not a whole number. So what we're going to have to do now is we're going to have to multiply this by a number so that it will equal a whole number. Okay, so you got to think. You got to do some critical thinking here. 1.3. The first number that we can multiply that times is 1. And guess what that equals? 1.3. Guess what? That's not a whole number. Okay, so now the next number we can try is 2. And that equals 2.6. Still not a whole number. Alright? The next number we could try is multiplied times 3. You see what we're doing here? We're just 1, 2, 3, until we get a whole number. I mean, you could have skipped in your head and got to 3 and said, oh, that equals 3.99. Well, hey, that's basically 4. So there you go. You got a whole number. So I'll keep it in green. So now we have the hydrogen is now a 4. But if we want to keep, we multiply the hydrogen. Oops. What did I hit? Okay, it's okay. We multiply the hydrogen by 3. 1.33 times 3 equals 3.99, which is about 4. So we multiply this part by 3. In order, remember, the 1 to 1.3 to 1, that is a ratio. So if we want to keep this all the same, we have to multiply these by 3 as well. So 1 times 3 equals 3. And then oxygen is 3. So there we go. We have our whole numbers. And let me put my little circle around it. There's the answer right there. That is the empirical formula of vitamin C. Now, it's not the molecular formula, it's the empirical formula. If you watched the video before, it explains how the empirical formula is the reduced form. So, this is all the info that they give us, and this is all we have to find. So, we're done with this problem, but let's do a recap real quick. I got 2 minutes to run through this real quick with you guys. Okay, so, it gave us vitamin C. And it just gave us the percent by mass, and it said find the empirical formula. So only it gave us the stuff in the black. If you're trying to skip the video and get to the quick explanation, we were only given the stuff in black. Now, because this is a percentage, we can assume however much we want. We could say 1 gram, 2 grams, 4 grams, 8 grams, whatever. But to make things simple, just assume you have 100 grams. If you have 100 grams, 40.92% of 100 grams is 40.92 grams. 4.58% is 4.58 grams, and so on. So we now have how many grams we have in this quantity that we assumed, and we simply convert it to moles. Go watch the video if you don't know how to convert to moles. And now we have the mole ratio. So we went from the percent ratio to, which is by mass, to a mole ratio. And the empirical formula, which we have right here, is basically a mole ratio. So these numbers can be inserted right here, which is what I did down here. That's finding the moles. Okay, so here's the mole ratio. We simply plug that number in, and we got this in the blue, but we can't have a decimal, so we divide it by the smallest number, and we get this right here, but we still have a decimal form. So what we do is we multiply this number, increasing numbers until we get to a whole number, and then whatever number we multiply this time, we have to multiply the rest times to keep the mole ratio the same. And there you go. That is how we find the empirical formula. And I have 10 seconds left.